Hi, I'm Panayotis, and I didn't know I did so many things. Thank you for the intro. So we're going to start with TensorFlow today, and I'm going to show you a little bit of highlights of what is TensorFlow, and then I'm going to show you how to embed TensorFlow on mobile devices and Raspberry Pis. You know what a TensorFlow is? I hope. Have you ever used it? Good. So I can bullshit you and you don't know if it's true or not. Perfect. I was waiting for the no things. I'm more relaxed now. TensorFlow is an open source machine learning library. It opened up a year ago from Google, and it's the bigger machine learning library on GitHub. It's for research and production ready, meaning that scientists and researchers are developing algorithms, and developers are developing and building apps. But what a machine sees, the vision for humans, it's pretty easy to recognize. Like vision for us, it's if I see an apple, it's an apple. The machine sees that as an array of pixels. So when you're building something or when you're building a model for training the machine, it's better to avoid the if statement. There are too many if statements that goes inside an apple, if it's green, if it's red, if it's big, if it's small. So it's better to translate them in an array of pixels. But let us go a little bit deeper into how the artificial neuron works. So as we said, to recognize images, we use a deep neural network, which means that you got raw pixels coming as input, you got artificial layers, and then you got neurons. The weight of the neurons at the beginning of the layers, they're not so heavy, which means that the accuracy of what the output will be is not going to be so accurate. But as you go up from the activated neurons, as you go up from the layer, the neuron are getting, well, you're not seeing it? You're not seeing it? Okay. The neurons are getting heavier and heavier, and the accuracy of the detection of an object is getting pretty much around 98%. A little bit more about TensorFlow. So we said that Tensor, it's a multidimensional array, which means what is an array? An array could be a number, 7, it's a tensor. It could be a vector, or a list, a matrix. A matrix is a tensor. And what we say about what is flow? Flow is actually the operation of that array that goes inside the neural network. This is a little bit of a graph. So you see that building up, you see that the neurons are going, the flows throughout a graph of operations, and then the gradients that come out automatically as gradients. The architecture is based on C++, high performance. I guess that everybody knows about C++ over here. Yes. COBOL, Pascal. Okay, you're my age. And so yeah, primarily it's built on C++, and then you have Python, mainly Python, because it's a flexible and high flexible language, and Go. But as many as you want to do, I don't know if there's any community over here and working, or will you work on TensorFlow, please try to do other platforms, because it's nice to explore new platforms for the TensorFlow. Runs on Android, iOS. It's got an optimized GPU and cloud mainly. Portable and scalable. You can use it on your laptop, well, data center, cloud, Android, iOS, and hardware like a Raspberry Pi. And now we're going to go inside the talk. If there's any questions, I'm not going to answer them. No, I'm joking. I'm going to answer them at the end. So my first question is, why do we need to build up, or do we want to build up on mobile devices? Mainly because users have an amazing experience, like snapshots. It's nice, I don't know, everybody, I'm playing a lot with the snapshot thing. Any of you plays with that? Good one. Grab a coffee later on. And Google Translation with a video. So you don't need, if you go on a machine learning embed on your device, you don't need to always ask to the cloud or to the infrastructure. So it's going to be like time consuming. I don't know if you ever tried, it doesn't work in Greece yet, the video translation. It's not supported, the Greek language. But it's pretty interesting to see working in, in action. And TensorFlow works with quite a lot of builder of devices, like chip builders. And that's why lately Google has done also a partnership with Qualcomm, which is important, meaning that that's the future that a big company like Google is taking into account. So as we said, TensorFlow supports Android, iOS, and Raspberry platform, and we're going to start with Android. But as I said to you before, if you want to try and build other platform tools, please do. I'm going to send you my email later on, and then we can keep in touch if you want. And I know that Google is looking for other platform to support TensorFlow, because they want TensorFlow to be on every single device, almost, and used on any single platform. I'm not a Java lover. I'm stating that, that's a statement. So if I'm not a Java lover, it means that I did a couple of apps on TensorFlow, and I don't know if we got some Wi-Fi connection or not. Well, anyways, I'm gonna show it, and then you can pass it over. It's like person detection. We're gonna go in through that later on. And so you're mobile developers, right? Almost. Android, you know Android? You go. Android Studio? Raise your hands. How many got Android Studio installed? Which version? Good one. So if you're developing for Android, you probably, use an Android Studio. It does use Bazel. Everybody knows Bazel is, right? Because I didn't know it. I had to find it earlier on. So you need to download and install it first. And then you need to set the link for your Bazel. If you do want to modify a TensorFlow source code, you need to understand a bit more about how Bazel works under the hood. So you install Bazel. You got instruction over there. And then you install TensorFlow. You need to install the latest version of Bazel, that's important. You need to declare both the general SDK and NDK version of the API you're going to use. When I built the app, I used Android Studio directly and SDK Manager. It's much easier to download everything. Once you download them, you need to take note of the SDK and NDK version. That's important because later on you need to input inside the template you're going to build. You need to add an incantation and update the workspace because sometimes you might want to build a lot of Android, a lot of TensorFlow apps. I just have a snippet that I can append at the end of my one-line commander. So you can just use it when you want to import your workspace. Run Bazel, basically. One thing to watch out for many apps like Benchmark and multiple platform, you need to have --config equal Android. It's not the case of this sample we are going to do now, I'm going to show you now, but if you want to build for benchmarking or cross-platforms, you need to declare the ---- config equal Android, or otherwise it's not going to work. So some Android examples. TF classify, that's what I wanted to show you. It's pretty, takes from the camera feed of your phone and gives you the object, that the percentage and the accuracy of the object that you're pointing at. It's based on the inception. I don't know if you ever heard about the inception model. TensorFlow for Poet. Thank you. Okay, and well, there are all models at Code Labs. I'm going to send you all the links later on if you want to work a little bit on those Code Labs. TF classify, that's really interesting because it gives you the classification of the object that you're pointing at. Can we show a little bit or not? Okay, you just move around. You just move around and point at the laptop notebook. Well, those are. It's a really interesting starting point for you to build your own app, and you just need to import and do the sample code. It doesn't recognize person, detects, not recognize. And well, if you want to go later on, you can go to the TF detect. Which one? Yeah.
TensorFlow in order to understand that this is a suite of. You made some training before?
Yeah, that's an inception template. The inception, it's a template that you downloaded and you train the TensorFlow model, and then you can change the images with your own custom images.
Okay, and you don't need any other service. Everything are running locally.
Yeah, you just run a TF. You just install TF, and then with the Code Lab, there's like a database of images. So it links to the database of images. You just change the database of images.
All right. Okay. Thank you.
How fast? Where are you? You haven't seen it on mobile? It's pretty fast. Yeah, I don't. Yeah. Let me show you. I don't know if you have ever heard about Vision, Cloud Vision API. Okay, if you go to Cloud Vision API and you upload a picture, you see in less than a second you see the sentiment and the text, the sentiment, and the persons. So it's pretty quick. It's not so quick on the Raspberry API. We're going to see it later on. You can take 1 day for compiling something.
This is with the time. If I leave the picture for maybe 5 or 10 seconds, do you have a better precision on the recognition?
Yes, but until a point, it reaches a point and then it stops. It's not that you're going to have 100% accuracy yet, or at least on a mobile device now. You need a DCOP.
Okay, thank you.
And if you want to change, well, just go into the menu and put the detect so we can see. This one is interesting, that detects, because it's got a tracking inside. So when when you want to build something with motion and tracking and app, it's really important to have the tracking enabled on the mobile, on your device.
So, one more question. Can you do something similar with audio? So,
With?
Audio. So, audio, with
Audio.
music.
Yeah.
Basically, classify the kind of songs that the phone is recording.
I know that they tried reading music, and then it comes out the sound. I'm not sure, well, speech. So the speech, but I'm not sure if there's I'm not sure if there's a training system for the listening to the way of the music and coming out with what if it's looking. And this one. Let's, yeah. Now she's who? Where? Well, she's gonna pass and see, yeah, some for the. No, wait. That was it. Wait a second. I'm gonna show you with the motion. Like I need a volunteer. Stand up. Okay, move a little bit around. Okay. No, doesn't. Yeah. Go right on your left. You see that? Yeah, now I moved it, but TV. Well, go back because you're out of focus. Stay there. Come towards me. Give me a kiss. No, I'm joking. Yeah, okay. So it's. I don't know if you want to play a little bit around. And really, it's important the tracking, because when you want to do machine learning apps, it's really important to have a track and a focus point on what you want to detect. Then we've got a few other examples, like Stylize that takes live video feeds, and you set the style you want to the video, which is interesting. I don't know if you went to the supporter area. There's an interesting app they're doing. Now, I'm not making any publicity, so, but there's an interesting app they're doing with video conferencing, and well, they want to integrate it in Hangouts. And we were talking earlier. This is just a little example on how into production is already machine learning. So if you want to, they are trying to autonomously tracking a video conference and understand if it's a task, if it's a to-do, if it's important, if somebody is missing inside the video conference. And with machine learning, this is going to be much easier for them to be able to implement their app. And especially if you put machine learning in analyzing video sentiment. So if you actually see from the expression of a face, the sentiment of and the weight of the word that the person is saying. It's like, well, we all know, I'm sorry for that, Malaka. Foreign people here, not from Greece? Who is not from Greece? Okay, do you know Malaka? Do you know what Malaka means? No, it's like, it depends how you say it. If you say Malaka, it's like you're a wanker. If you say, come on Malaka, it's like, come on buddy. I don't know if I'm wrong or right, is that right? Okay, the machine learning can understand the sentiment of the weight of my voice over the word I'm saying. So, TensorFlow is in C++, and you're Android developer, and you're building in C++, yeah, Java. If you're building in Java, there's an Android inference library, and that's what you need to call in order to be able to integrate TensorFlow in your Android app. It's pretty easy. There are pre-built binaries, and or otherwise, if you want to do like a cross-platform apps, you need to see the full TensorFlow Java API. It's interesting because it's been opened 3-4 months ago, the whole Java API. So it means that you can build everything you want for your Android app and combining it with TensorFlow. iOS, any developer iOS? Out. No, I'm joking. iOS, so TensorFlow is fully supported for iOS, which means that, well, you're a mobile developer. If you are, or most of you are mobile developers, they might be interested in developing an app for iOS as well. Oh, my mobile phone is somewhere hidden. Yeah, you're gonna develop an app for iOS, and TensorFlow is fully supported for you to be able to integrate machine learning into iOS. Xcode and Makerfly files, sorry. So you need to, well, I use for some examples Brew, because it's, I'm more familiar with Brew, but you need to install Automaker and libtool. Those dependencies installed, you just run the full TensorFlow library in about 20 minutes. Iterative builds. What you need to do. At the end, you have a universal library implementing TensorFlow in all of its architecture plus a bit code. It means that if you're going to make any changes in the steps before, you need to refresh and re-upload every single steps. It's important to put the -OS flag, which gives you the Apple's Accelerate framework, because otherwise it's going to be too slow. And once you have built the library, you just need to link against those libraries, the TensorFlow, the protobuf, and you need to include all the paths correctly, otherwise it's not working. And it's very important that you put this, we're going to tell it later on, -force_load. Otherwise, your app will not running. So iOS examples, I choose some really ugly UI, because it's a competitor. No, I'm joking. This is, the interesting thing is that with this one you can do emulation, like it's an emulator. So it takes pictures from a database, so you don't have to go around and try to see if what you built works or not. If you want to make it a little bit more fancy, you just put the camera example. So there's an example, so you can download the sample, and you just put the camera and it makes it a little bit more interesting. Raspberry Pi. If you got any question about Apple, ask those two guys. They might be more clever than I am on Apple development. Raspberry Pi, it's fun to have Raspberry Pi and to build machine learning apps on Raspberry Pi, and because actually you feel the hardware. It's really nice because you feel it, and when you make an app, either it's an image recognition app, either it's we built one day we built something like switching on and off another people's house by recognizing who he was entering in, which was interesting. As I said before, the only things that you need to do is, sorry, I lost the slide. So it's like Linux machine, but as I said before, when you try to build a machine learning on Raspberry Pi, it's really time consuming. I still don't recommend cross-platform because it's a bit tricky to set up it correctly. It's sometimes you don't understand where the problem is, so it's better to wait a little bit more, but do it on device locally. So the PI build process uses makes files, and one thing to note is that the libtool is 4.8. With 4.9, which is the latest on Raspberry and that comes with 4.9, we found some issues related in compatibility with TensorFlow. They've been covered up, but I recommend you downgrade to 4.8 in order to have a smooth experience. So once you have the dependencies installed in a protobuf build, you can build the main library using make. You just run this make file. Again, 4.8, really remember it. And you're set up. The newer version of PI, I don't know if you're using 2 or 3, PI 2 or 3, anybody? Actually, anybody of you has a Raspberry Pi? 1? Version 1 or the latest version 2, 3? 2? Okay, so you know that you have the Neon SIMD inside, and that, like, if you're trying to build on Raspberry Pi 1, you take, well, the app we did took us about 18 hours, which is, yeah. We left it, we went for a beer, and we went for another beer, and we went for another beer, and we came back, and nothing was compiling. With PI 2 and 3, you break it down to 3 hours. So you just have 3 hours in order to be able to do a simple app. A few examples if you want to see. It's label image, yeah, which they are the same examples but on different devices. That's the main thing. The only thing that is nice with, I'm going to be quicker. The only thing that is nice, sorry, with the Raspberry is that you can attach it to the text-to-speech. So actually, it can say to you what the Raspberry sees. So if it sees an apple, it comes back to you, apple. No? No, okay, don't worry. The fun fact, so you remember that I'll say to you the -force_load linker that we needed to put. That's why when you run your app, you have no session factory register. And this is, well, this is because the TensorFlow, wait a second, is built on 100 different components, and each component has got its own implementation. And TensorFlow hasn't got one list that lists all of the components he has. So it's like it's more like advertising itself. Like, hey, I'm here, I can do that for you, but it's not really listing what it can do for you. And if you don't put the registration patterns, as we said, that means that the registration doesn't success because it doesn't link to the registration itself. Just implement this, like you put the you need to declare it, saying if you have a mul, like a multiply components, please register this one in your operation, and that clears out the main problem about the registration process. So that's nice theory, as we said, but linkers are still stuck in 1978, and well, they don't understand C++ at all. So when they see a registration on global constructed by macro, the same analysis knows nobody ever Earth, it goes variable. So you just do a global variable, can have side effects. And that's the solution. So minus minus whole archive. That you put that solution and you put the minus force underscore loads. That's if you put that, you don't have any problem in building your app on iOS with machine learning. 15 minutes. Yeah, I won't back my phone first. Okay, 15 minutes. Okay, size and speed. So we speed it up a little bit. You know that as a mobile developer, you need to make an app that is not heavy for the user to download. And Inception v3 is 93 megabytes, which means that it's heavy and it's not really a user-friendly app. But there's a few tools that you can use in order to make your app less heavy, lighter, and quicker. So a phrase graph is one of those tools, and it combines convert your model into a format that can be accessed easily on using the phrase graph script. Graph transform tool. The graph transform tool is a handy toolbox and optimize graphs, and it gets rid of the nodes, of the weight of the nodes that you don't need. Quantize weights, shrinking models. So the most important tool is to quantize weight transform, which means that it contains, on TensorFlow, nodes weight 32 bit. And with this quantized weight, you cut it down to 8 bit per node, which is quite a big, it's quite a big decreasing of size on the node. And that's if you want to get a little bit more sexy. It's still experimental future, but you have the quantized nodes, which does calculation in 8 bit, which it doesn't. It's not you don't only transform calculation in 8 bit, but you do calculation on 8 bit. Memory mapping. So if you use all those tools, you cut 1/3 of the Inception v3. So it means that for 90, nearly 100 megabytes we had earlier, we're going to have 24 megabytes with all those tools. If you want to have a smaller app, you can use the Inception v1, which is 7 megabyte. So it's not so accurate. So if you want to do something accurate, better to go on the Inception v3. Executable size. So it's not only it's also the speed. So how big is your binary? It means how does TensorFlow work with your binary? And if you put TensorFlow as a library, it increases 12 megabyte your app, which is another scary number. Default size, yep. So what you do to avoid excessive load, actually include some operations that are typically only used during training. So if you want to train your model, you know that you're going to have an X amount of megabyte in execution. If you want to use your app, you just cut down the training model. So the TensorFlow knows that in this case doesn't need to go in training itself, but it already knows what he has to do. Selective registration, it's micro-enable, and you're going to see a much smaller, finally, binary on the operation the app is doing. So this shrinks the binary size increase to under 2 megabytes, which is include in the Inception v3. That was my presentation. I guess I'm on time.